yesterday we talked about lots of different things, okay? We didn't put the lesson on YouTube, sorry about that. But we talked about mins and maxes and relative mins and relative maxes, okay? So I'm going to give you a problem. I want to see how good you are at this, okay? So, during... Oh, I bet you're good. A 24-hour period. The temperature Y of a certain city is modeled by this equation. Yes, the hours is the X. Modeled by, and here's the equation. Y is equal to 0.026 x to the third plus, minus 1.03 x squared plus 10.2x plus 34. All right, now stop. Don't stop paying attention. Okay. X is restricted from what?
Greater than
0,
but
between 0 and 24, because I said during a 24-hour period. Now, watch what else they do. This, you're like looking at that, you're like, oh, okay, I can do that problem. But now they're going to throw something really weird in there. X is equal to 0 corresponds to 6 a.m. in the morning, of course. So, here's what I want to know. Can you find the max temperature and can you find the min temperature? And not only can you find them, but can you tell me when they occur? All right? So, I'm going to give you a few minutes. All right? I want you to do it. Huh?
They do it 6 a.m. to 6 a.m.
They're not doing 6 a.m. 6 is not 6 a.m.
I know sometimes just like the end of the number will be really 6 p.m. or 6 a.m.
Yeah. I want you to think about it, but I'm glad you at least thought about it. Okay? I want you to think about what is the X and what is the Y, and what would be a good window to have.
24, 0.
Yeah. Yeah, the Y you got to kind of think about it, because you don't know. I didn't say where it was. I didn't say we're in Anchorage, Alaska. Okay, their highs and lows might be a little different from Hawaii or Orange, Texas. What? when it occurred. Alright, y'all got him? Okay. What did you get for the max temperature? 63.9 degrees. When do you say it occurred?
I didn't get that exact. I got
12:36 what?
PM.
Which one?
PM.
Okay, it is PM. Alright, let's talk about how we can figure this out. Alright? So, here's the first thing. I'm going to explain all of this, okay? Because y'all are the only class that said, hey, what about those windows, Miss Davis? The rest of the classes did this, okay? I mean, they go Zoom 6, because that's normally what I do. And then they looked at this, and some of them just said, whoa, I don't know what to do. And then some of them just started zooming out. And I'm like, you know, instead of just like rolling the dice at it and hoping you come up with something good, why don't you just think about it a little bit? So I said, let's go to our windows. All right, what about my X's? Did they give me a min and a max for my X's? Yeah, they said we're going from 0 to 24. So that's what I'm going to go from, 0 to 24. What'd y'all go on a scale of? 2? Good. All right, now the Y's, they're not as easy because it's temperature. We don't really know. If you were in Anchorage, Alaska, -10 could possibly be a high for the day, right? Okay? But I'm just going to leave it at -10. Now, I don't know how high to go, but I'm pretty sure that most of us get above 10 degrees. So I'm just going to go to 100, all right? I mean, that, you know, it gets to be around 100 sometimes. I know back in Arkansas it would be 100 a lot of times in the summertime. Okay, and I'm going to go on a scale of 10. And then we graphed it. And we got an amazing graph. A perfect picture of what I want to see. There's my high, and there's my low. There's my max, and there's my min. So we're going to calculate that max. That's what we did yesterday. So I'm going to go second and calculate. I'm going to choose number 4, which is a maximum. He's going to ask for a left bound and a right bound. Okay? Because we learned that really this is a relative max, right? Relative to this general area, what is that maximum point? And that's important because the rest of the curve may not mean a lot to me. Okay? So there's my left bound. Thanks, Don. No. Minimize that calculator. Yeah. Oh, he's still connected. Just, oh, okay. Alright, thanks. Okay, so, where am I going? Right here. Alright, so there's my left bound. I'll press enter. Now he wants a right bound, so I'll go to the right. Press enter. and then I want him to find it. So there's my maximum. Now remember yesterday we talked about this, and I said, if someone said, what is the maximum, who would you choose, the X or the Y? The Y. This is the maximum. The X is when it occurs. Okay, so that's where we got the 63.9. All right, and this is where the 6.6 came from. But that wasn't in our answer. We just had to use it to get our answer. So let's talk about the 6.6. Well, even if you look at the picture, though, I think it's cool. If you look at the picture. Y'all, this is 6 o'clock in the morning. What's this right here? 6 o'clock in the morning. Okay? So this is a little ways in. That's going to be about noontime, right? It looks like it's happening around noon. That makes sense for us. A lot of times that is the high. Okay? So let's go back and see what we need to do with that 6.6. What did you do with the 6.6? Added it to 6. So I got 6.6 plus 6, and now I got 12.6. Well, that's where the 12 came from. It is p.m. because I was started at 6 a.m. Once I passed 12, I'm at p.m. Okay? But where did the 36 come from? Yeah, you just got that 0.6. That's the fractional part of an hour times 60 minutes, and it'll tell you that it's 36 minutes. So 12:36. Okay? All right, so if you hadn't gotten this one, now you ought to be able to get this one. So we'll go back to our calculator again. This time we're going to calculate this minimum. So I'm going to go second and calculate. I'm going to choose number 3, which is a minimum. He's going to ask me the same directions, guys. Left bound, right bound, lady. All right, so I'm going to go over here. Oh, I probably went too far. Oh. Left bound and right bound. So here it is. My minimum temperature is 33.98, so I'm going to call it 34.0. Okay? That tells somebody it wasn't 34, but I rounded it off. Okay? So 34.0. And then I got this 19.8. Now that messed a whole bunch of kids up. Alright? So 34.0. And what was it? 19.8? What am I going to do with that 19.8? I'm going to do the same thing with it. I'm going to add it to 6. Now I'm going to get 25.8. And then they're really messed up. So what are you going to do? Yeah, I took 24 out of it. Now I'm left at 1.8. Now it's 1 when? A.m. in the morning. Okay? And how many minutes? Well, take that 0.8. That's the fractional part of the hour. Multiply it by 60, and it'll tell you that it's 1:48 a.m. Okay? Pretty good problem, right? Using skills we learned yesterday. Using them for a purpose. All right? Now. No. All right. So, this is the next thing I want to talk about. This is going to be on your test. For some of y'all, it won't be a big deal. But I will say, on my last test, one page had 3 piecewise functions on it, and there were quite a few papers, and there was nothing written on those graphs. So, I'm going to put them on there again. People, if you don't know how to do them, you better figure out how to do them. I'm going to show you, it's basically the same way, but it's probably using your calculator more than what I showed you last time. Alright? So, here is the piecewise function we're going to graph. F of x is equal to 2x plus 3 when x is less than or equal to 1, and negative x plus 4 when x is greater than 1. Well, there is, but I'm not going to show that to you. But there is a way to put it in your calculator. And here's why. Because I want you to at least have to think about something. Okay? But I did try to tell them, because I don't know what the deal is. I don't know how you can get to be in the 11th and 12th grade and not be able to graph anything when you have a crazy calculator in your hand. Okay? That just seems insane to me. So, I'm going to just show you another way. We kind of talked about that way, but we did everything by hand. So I'm going to show you a little more how to use your calculator. But there is a way to put it in your calculator and do the domain. Well, we carved it and hammered it in the stone, and then everything to the right of 1, we got we sander out and we sanded that part back down again. And then we graphed this, and everything to the left of 1, we sanded that part off again. And then we had us our piecewise function. Okay? So, now honestly, when I was in high school, that's the way we were taught to do it. You graph this line on this coordinate plane, and then you take your big eraser, and you erase everything to the right of 1.
Did y'all like graph, like hard stuff?
Yeah, yeah. But we didn't, it took a long time to do that.
I didn't, you never know if it's right. You never even see an example of it to see if it's right or not.
Well, we did. Mr. Houston would graph an example for us.
I know he's
Okay? Oh, it was Mr. Houston. Please. My most favorite teacher in the whole wide world. Okay? I love him. Mr. Houston. And that's all.
Oh my God, that's so weird.
Okay, so.
All the teachers were like,
I bet they were. No. No.
you didn't do some funky, you're winning?
No. No. Okay, so here we go. So this function right here, where does this line occur? To the left of the dotted line or the right? Left hand. Left. So y is equal to 2x plus 3. Okay? So, now guys, what is the one point that I want to see on your graph?
The line.
Yeah, that's right. That 1. I want to see that 1. I want to know what this function does at that point where everything changes. Okay? So if you don't do that, you're going to lose a bunch of points.
Wait, we have to draw it.
Okay? You don't have to draw this line, but that's where I'm looking. Okay? You don't have to draw a T-chart because I'm going to be looking on your graph. But I want your points on your graph. So go to your little calculator. Okay? Put that thing in there. 2x plus 3. I mean, if you want to look at it, people, go zoom 6 and go, oh, all right. Here's that line. I'm going to draw this line up until it gets to right here. But I'm not going to just try and copy it on my paper. People, I'm going to go to my T-chart. Okay? I'm going to go second in table. And I want the point, 1, 5. What else do I want? Yeah, it takes 2 points. I want at least 2 points. Now, if it's a curve, it might take more than 2 points. Okay? So, but a line, I'm good with 2 points. So I want the one 1, 5, and then I'm going to use -2, -1. Okay? So, 1, 5, and -2, -1. 1, 2, 3, 4, 5. Here's 1, 5. Is it solid or hollow? Yes, it's or equal to, so it's a solid dot. 2. Yeah, look. If I make a hollow dot, and then I put a solid dot on top of it, what is it, people?
Yeah, but what if there's 2 lines coming together?
It doesn't matter, y'all.
Well, which one's equal to?
It doesn't matter.
Like, I didn't know you...
No.
I'll just make a solid dot and then put a...
That's what y'all usually do. Y'all usually make a solid dot and then put a little circle around it. Okay? But y'all, if you have an open circle and you put a solid circle in it, what is it going to look like?
You just have a better chance of getting it right.
Yeah.
It'll still, if I put an open circle on top of the solid, it's still going to look like a solid circle. Okay? Huh?
The open circle's bigger.
Well, yeah, it'll look like this. That's what y'all do. All right. So now I'm going to draw the line. I missed my point. Sorry. I have to make a big fat point. All right. And then this one right here, y is equal to -x plus 4. What point do I want to see, guys? I want to see the 1, and I don't care whatever the other point you put. All right? But, guys, stop leaving these piecewise functions blank. So go to y equals, put -x plus 4. If you want to see what it looks like because it makes you feel better, there it is. It's going to start right here, and it's going to go down. I'm going to go to my table. I want to see the 1 and the 3, and then you can pick 3 and 1, or you can pick 4 and 0, or you can pick anything else, all right? So I'm going to go back, 1 and, what was it, 3? Open or solid? Open, right there. And then 1, 2, 3, 4, 0, and this is what it looks like. Okay? So you're going to have some piecewise functions. Guys, there'll probably be one on the review, but you're going to have some on the test. We've been talking about them. We ought to be good at them.
Are they going to be the easy ones like that, or more like a little bit complicated?
Yeah, there could be some of those. Okay? Because we're going to talk some more about those. All right. So let's talk about even, odd, and neither. Yeah. Which is not I before E except after C. Yep, another bad English rule. Okay? Even, odd, or neither functions. Okay, so let's talk about even functions first. If something is an even function, it is symmetrical to the y-axis. Now, here's what I'm saying, guys. Is that symmetrical to the y-axis? That's an even function. Okay? Also, another way to look at it is f of x will be equal to f of negative x. This is more like what we're going to talk about. Okay? Going by looks is very dangerous. Okay? Don't ever go by looks. It's better to be algebraic. So we're going to find it algebraically and prove it's either even, odd, or neither. All right, let's talk about what an odd function looks like. An odd function is symmetrical. This one's a little bit harder. Symmetrical to the origin. Now, this is what that looks like. When something's symmetrical to the origin, you you know how this one you can flip it over the y-axis and it lands on top? When it's the origin, you have to flip it twice. You have to flip it over the x and then over the y, or flip it over the y and then the x. Pardon me. So let me show you an example. This function right here, okay? Now you can do it either way. If I flipped it up here, do you agree that it would look like this? You with me? And then if you flipped it over the x, it would land right on top of that yellow one. You see that? That's symmetrical to the origin. Now watch, you could go the other way too. I could flip it this way first, then it's going to look like this. You see it? And then I flip it up, and it should be on that yellow line. Okay? That's a cube root function. Okay? All right. But there's different ones. Remember what I said. We're going to do it algebraically. So in order for it to be an odd function, f of negative x is going to be equal to the opposite of f of x. Now, when we start doing these, you're going to kind of remember them. Okay? So here's what you need to know. If f of x is equal to f of negative x, what is my function? Even. If f of negative x is equal to the opposite of f of x, what is my function? Odd. People, if those two things don't happen, it's neither. Yeah. I mean, it's either this, or it's neither. All right? It doesn't have to be even or odd. It could be neither. Okay. Huh? No. All right. So let's do one. Let's do this one. F of x is equal to 2x squared plus 4. Now, you agree that we got to look at three things. You got to look at f of x, f of negative x, and the opposite of f of x. Everybody agree? If these two are the same, it's what? even. If these two are the same, it's, if neither one of those things happen, it's neither. Okay, what is f of x? 2x squared plus 4. Alright, how do I find f of negative x? Yeah, you plug a negative x in for x. So that gives me 2 times negative x squared plus 4. Well, when you raise a negative to an even power, what happens to the... Yeah, it goes away. It's positive. So that becomes 2x squared plus 4. Oh my word. What do I know? Yeah, look, those two things are the same. This must be an even function. Okay, you see? It's not hard, is it? Alright, let's do one more. I'm going to let you do this one all by yourself. And then we'll be finished. F of x is equal to x to the third minus x. Remember, you just have to find 3 things. At the most. I mean, up here we didn't even find the third thing because I didn't care. I already knew what it was.
How do you, choose that?
Okay, let's look at this one for a second. Alright? There's my f of x. Let's look at this because the bell's going to ring in a minute. Well, not really because we don't have bells. But when you raise a negative number to an odd power, what happens to it? Yeah, it keeps its sign. So that's negative x to the third. What's the opposite of a negative x? Okay, so, man, he's not even, people. Okay? Now, what is this thing asking me to do?
Multiply the whole equation by
Yeah,
negative.
he says, hey guys, take the opposite of the whole entire thing. So, what's the opposite of positive x to the third? What's the opposite of negative x? Oh, so what is that thing? He's odd. Very good. So we'll do some more tomorrow, okay? We'll do some more tomorrow.